In this example, we're given the function y is equal to e to the sine x, and we've been asked to calculate the value of dy by dx when x is equal to pi. So the first thing we need to calculate is dy by dx. And to do this, we need to recognise that we have sine x and we have the exponential function. So we have a function of a function. And recall, to differentiate a function of a function requires us to use the chain rule. Now the chain rule tells us that dy by dx is equal to du by dx multiplied by dy by du. So the first thing we need to do is define what our u is, and the u is the one inside the other function. So our u here is sine x. And if u is sine x, therefore our y becomes e to the u. So now we've defined our y and our u, we need to also find du by dx and dy by du. So du by dx requires us to differentiate the u with respect to x. So we get sine x differentiates to cos x. And y, when we differentiate it with respect to u, well, that just stays the same. Recall, when we differentiate the exponential function, it stays exactly the same. So we can now write down dy by dx. dy by dx is du by dx, which was cos x, and then multiply that by dy by du, which was e to the u. But recall that we define u to be sine x, so we can see dy by dx is cos x multiplied by e to the sine x. So this is our dy by dx. But the question wanted us to find the value of dy by dx when x was equal to pi. So we need to take the dy by dx and we need to evaluate it at the point when x is equal to pi. So that takes us to cos of pi multiplied by e to the sine of pi. Now, cos of pi, you should recall, is equal to minus 1. And then we have e to the sine of pi. Now, sine of pi is 0. And we have e to the 0. Now, anything to the power of 0 is equal to 1. So we have minus 1 times 1, which is just minus 1. So we can say that the function y is equal to e to the sine x, its derivative evaluated at x equals pi is equal to minus 1.